All right, welcome to our 6th unit of general chemistry. This one deals with equilibrium. Equilibrium, you will learn very shortly, deals with concentrations of solutions, which, well, that means the first thing we should probably talk about is what in the world a solution is. And, well, welcome to your introduction to solutions. So, a solution is a homogeneous mixture of two or more substances, which implies that they are uniformly dispersed throughout a single phase. These are examples of solutions. Now, hopefully your first thought is, wait a second, Mr. Booth, how do you know those aren't just, red, yellow, green, and blue colored liquids? Because A, they're all water with food coloring. And B, I just happen to know that it's probably not them. So, solutions are basically when you've got something completely mixed. It's the same thing as what we call a homogeneous mixture. So the main definition comes down to, say you got a beaker with water, and I got tons of dots everywhere. If a solution is properly done, then any random sample of this, of the same size, should get me the same concentration, which, as you can tell from mine, it doesn't quite. Now, that is quite opposite to a heterogeneous solution, or mixture, in which any sample can easily be different. So, solution, also known as homogeneous mixture, are when two or more substances are uniformly dispersed throughout a single phase. Phase, by the way, means basically state. So, basically, if you look at these, they're all liquid. You're not having chunks floating around. They're all liquid, or it could be all solid or even all gas. So, yeah. So, when a mixture has particles distributed throughout that eventually actually settle and separate, this is a heterogeneous mixture, but we actually call it a suspension. Now, the reason I mention this is a lot of people think solutions are when you take stuff and stir them together. Well, sometimes that helps. Oftentimes when you stir them together, they don't stay together. Think of old-fashioned peanut butter. Think of some salad dressings. Think of oil and vinegar. Things that look mixed, but you give them enough time, they kind of settle out. So what's happening is this is a solution. You'll notice it's all the same color. Suspensions are like when you put whatever that thing is, at a given time, they kind of float to the bottom. So here kind of looks like a solution. They're, dispersed a lot. Yeah, no, they're not. So yeah, that's the difference between a solution and a suspension. Precipitation, by the way, is what suspensions often look like. Precipitation more means you put two things together and they make their own solid. So, yeah. So in a solution, the substance in which the solute is dissolved is called the solvent, which basically means that whatever is being dissolved is a solute. So, for example, let's say our solute is this blue sketchy chemical stuff, and the solvent is this clear sketchy chemical stuff, also called water. If we take that stuff and stir it around in that water, we get this, which is an example of, I think, copper 2 chloride. That might be wrong. This is a solute. This is a solution. This is a solvent. This is a solution. When we dissolve our solute in our solvent. Now here's the kind of trick. The only difference between these is typically there's more solvent than solute. So there's times where there's two liquids and they're saying we're dissolving this and this, but they're like, which one's the solute? Just figure out which one's less. So there you go. So when dissolving, there's actually a small little process going on you may not have known about. The particles of the solute have to break apart because, keep in mind, they're kind of all together. And actually, the solvent has to break apart to basically make space for the solute. Okay? So now you've got broken apart solute, broken apart solvent, and then they actually mix together. That'll come in handy, especially if you take AP Chem. As you can see, there's actually some enthalpy values associated with this that we don't care about right now. But how they dissolve is basically they're breaking apart and then remixing and bonding kind of and being attracted basically to the solvent. So there you go. All right. Alloys are one last type of special solution They're when solid metal is mixed with other solid metal, like a very common example of bronze. There's actually no element called bronze. Just surprise. Okay, in AP Chem, I'll actually tell you there's two types of alloys, so I might as well show you now. Sometimes alloys actually have different metals replacing the actual other atoms. Sometimes they're in between them. So, two types of alloys. Common example, though, is gold. I mean, wedding rings. This is basically a chart of how most colors of rings involving gold look. A lot of people like white gold. Well, white gold is mainly silver. Maybe a little bit of gold. Okay, pure yellow gold, that's, 90% gold, but not much silver. And all of this represents basically different colors of all the alloys we can have. Whenever you hear phrases like 14 karat gold or 18 karat gold, might as well write this up here, it's kind of cool. 14 karat gold is actually equal to 14/24. I know, don't ask me where the 24 came from, it means carat, percent gold. So the purest you can get is 24 karat gold, which would be 24/24. And no, you don't need this for your test. It's just kind of cool information. So that means that the higher the carat of gold, the more pure it is. That means, however, for here, the other 10/24 are other metals, meaning that's an alloy. This is actually not an alloy. It'd be a pure element because it's pure gold. But again, that really doesn't matter to you. It's just kind of a cool example. Remember that alloys are solutions of two different metals. Okay. Lastly, there are many ways to separate mixtures into their individual components. However, none of these will really apply to solution except for mainly one. No, that's a lie too. So, you normally don't separate solutions. Now you can, and I'll show you which one doesn't apply. But here you go. Chromatography. This can separate solutions. It separates mixtures by difference in attraction. Very common example is take a piece of paper, put a black dot on it, and basically you stick that in some kind of water, and you let the water rise up. What happens is some of that ink is attracted to the water, like the yellow. Some really isn't. So it'll kind of start spreading, and you'll basically separate the ink in your pen. Just go try that at home. That's how when water touches the corner of your paper and it spreads the ink over your paper, yeah, that's chromatography happening. Yay, chemistry. All right. Distillation also can separate solutions, and it separates by difference in boiling points. Okay, whenever you say distilled water, that's what this means. Basically, we take something and start boiling it. And you try to heat it right to a boiling temperature higher than one of the things in the flask, but lower than another. So that thing starts boiling and turning into gas, and then we cool it down and turn it back into a liquid. So you end up separating the liquids out. Often like salt water, think about it. You boil off the water, catch the water somewhere else, and all the salt is left here. All right, last one is filtration. This will not separate solutions, but it's very common in chemistry for separating actually heterogeneous mixtures. So you take a piece of filter paper and you put in this mixture. All the solid residue kind of floats to the bottom. The water is able to pass through the filter paper, and you end up, or whatever it is, and it ends up actually collecting in somewhere you're collecting it in. So there you go. All right, main thing though I need you from this unit, from this video, is to know the difference between solute and solvent. So take a few minutes, try and figure out what the solute and solvents are of these three compounds, these three solutions. Okay, welcome back. So, coffee with milk is basically when we dissolve milk in coffee. That means that is going to be our solute, and that is our solvent. I lied. Coffee is our solvent. Milk is our solute. In salt water, we are dissolving salt in water. That means water is our solvent, salt is our solute. By the way, almost any time you see water, it's going to be your solvent. Tea with some honey in it, our tea is going to be our solvent, and honey will be our solute. If you happen to tell me that water was our solvent and like the tea bags and the honey are solutes, that's also fine. That's kind of, a little bit better actually. But there you go. Solute is what you dissolve in the solvent. that finishes our video for today. Thanks for watching.